Nice audience. Hello, everyone. So today we're going to be talking about OpenSearch, Python, and Serverless. So my name is Laysa Uchoa. It was actually pronounced correct, which is quite unusual. So thank you. And I'm here today with Yuliia Barabash. We are both located in Munich, in Germany. And we work providing cloud solutions. We work a lot with Python, Terraform, and all the things around. And also, we work a lot with AWS. So what's the content of this talk? We're going to talk a little bit about general databases. We're going to talk about what kind of problems databases solve and what kind of problems a search engine is specifically solve. Of course, we're going to talk about OpenSearch. And we're going to teach you how can you do autocomplete with OpenSearch today with a demo. So, what are databases? Databases are used for store, manage, and retrieve data. Why do we have so many databases? Actually, I looked up and it says that we have more than 300 databases. It's quite a lot. And every day, new company, new database. But why do we have this? It's because we have different kinds of data. We have structured data, unstructured data. We also have different ways that we want to retrieve data, different business case, and so on. I just put a few of them here, graphical databases, key value databases, NoSQL, SQL, and all the NoSQL tastes of databases you can imagine. So I will talk about a real scenario. So first we started our application that we wanted to have a database, of course, one of the 300s. And we chose DynamoDB. DynamoDB is a key value database that basically you can pick up by the key, and it's quite fast database. It also has support for JSON, so it's quite nice. And it was okay for a starting point. So via using lambdas functions, we could interact via the API, take data, put data there, and so on. And this works great until you try to search. So when we try to, our client actually wanted that we are able to search across all fields and across all documents. And key value databases are not the expertise, is not searching. So it wouldn't work so well, it didn't work so well, and people get stressed. So how can we solve this? Should we just delete everything, delete all the code and leave it away? I guess not, because that's not good practice. So we just extend this. Instead of just using DynamoDB, we continue using DynamoDB as a source of truth, because DynamoDB is very good on that and is reliable, and we already have the code for that. So what could we do in this case? We could integrate our beloved OpenSearch. So now every time we send data to DynamoDB, we are sending it to OpenSearch. And every time we need data, in the search expertise, we don't ask DynamoDB anymore, we ask OpenSearch. So this is actually quite nice and makes our client happy. Nice user experience. So, but what kind of problems does search engines such as OpenSearch actually solves it? I will tell you some of them. One of them is that we live in a beautiful world, and I'm actually quite happy that in San Francisco is quite bilingual city. So I can see everywhere 2 languages, and around the world, of course, we don't speak only English. So different languages have different ways that we store data, and also different ways that we need to retrieve this data. For example, in the German language, you have something called compound words. What is that? Is when you have 2 words and you put it together, and this one word, like orange juice, is not orange and juice, it's together in German. And this is something that it definitely affects when you search for a word. So you're not going to be searching the same way that you would search if they are tokenized separately. So it's quite nice that OpenSearch actually can speak several languages, because OpenSearch is multilingual, has support for several languages, and for me it's a very nice feature. For humans it's also a nice feature. So let's go to the next point. Of course, we are not robots and we make mistakes. When we type, we may make some typo, but for example, you still can understand this message. And this is why, because we have this fuzzy searching algorithm in your heads that will try to match with something that makes sense. And OpenSearch is so smart that actually also has it. So it's quite nice that you can still believe in yourself, even when things are a bit wrong. Another nice feature, I saw someone wanted to make a picture. Now I feel like I should move it back. Okay, you can make a picture. Never forget this sentence. So imagine this one is also quite nice. So you go to the search engine, you start typing things, the search engine quite reads your mind, and you like, what's happening? The thing is that a lot of the search engines, and also, of course, OpenSearch has support for auto-completion. So when you stop typing something, it will go try to pick up relevance results. Hello? It's over. It's over. Hello?
Hello.
Yes. Someone help me. Hello?
I think. Hello, hello.
I will try to go in this one. No problem. So OpenSearch has auto-completion, which is like, as I say, you start typing and it gets in your mind. Going to the next point is also, this is also quite nice thing, and it's also very useful. For example, when you are sending your logs to OpenSearch, you don't want to, sometimes you don't want to define mapping beforehand. And it's nice that OpenSearch, different of a lot of SQL, or probably most of SQL databases, you don't need to define the mapping before you start using. So one of the nice features that OpenSearch has is dynamic mapping. But also, OpenSearch has other friends. Another interesting feature is that OpenSearch has many integrations, especially with the AWS environment, but also with other tools. And plugins, so many plugins. So I said here quite a few, but there are many more features in the OpenSearch, and every day has new support, especially with machine learning. And how does OpenSearch does all that? So OpenSearch uses inverted index, and you could imagine that index is something that you would go and look over the documents and try to find the words there and so on. But the way that OpenSearch does is actually finding the words and trying to have the document where those words can be found, and also having a score for that. And this is also a very nice thing, but enough of theory. Let's understand how can you actually, for example, implement auto-completion. So maybe we're going to be able to read someone else's mind.
So, thank you, Laysa, for your part. And now let's talk how basically implement auto-completion. Auto-completion is quite nice tool, especially sometimes user can be lazy and you want to help them to search and speed up, and also to push sales. So it's quite nice to have OpenSearch auto-completion as well. And let's talk about how basically to implement. Additionally, at the end, we will have a demo where we demonstrate is how basically auto-completion works. And let's start with describing that right now exists 4 different methods how you can implement auto-completion. But one, it's called prefix matching, H and grams, search as you type, and completion suggester. And grams matching and search as you type, it's very, very similar in the nature. And also search as you type have better performance. That's why we focus today on the prefix matching, search as you type, and completion suggester. So we will start with the easiest one. In case, suppose you want to do POC, you don't want to invest a lot of money in your solution. You want to check if people won't use this solution at the beginning. Prefix matching is a perfect solution because you don't need to change your indexes, you don't need to analyze your data, you just need to build suitable query that match your prefix. It's quite easy. And for this, we need to use special kind of the query. So as it said, we are Python developers, we know Python, that's why we are using OpenSearch Python. It's a nice high-level library. In case you want to have wrappers around your API's calls, not to do raw calls, and also it helps to manage exception, help to manage cluster indexes and data, you can use OpenSearch client. In basically, client will represent your connection to OpenSearch. From your machine, it will keep a session, data session, and often metadata for the session. And we will start with a simple call search. And also, we need to specify the index that we want to use. In our case, it's basically movies. We would like to search for the movie. And we would like to search for a specific kind of the movie, with specific title. That's why we specify title, and also we specify the name, beginning, what type of the query it should, what type of the prefix our query should match is Harry. And also we need to specify that it should match prefix of the phrase. That's why we use match phrase prefix. Great. And for this, basically, what you need to implement this solution. So no changes to the index, just cool query, and you have your solution. Even it brings a lot of benefits, it also has some drawbacks. In case you have a lot of data, performance will be not so great because your index is not optimized for efficient retrieval. That's why we have the other approach that can help you with performance. One of them is called completion suggester. Completion suggester is another type, and also it's suitable for faster retrieval and low latency requests, because what it does, it builds special data structure inside memory of OpenSearch that will help to analyze and retrieve data in very fast manner. And to let know OpenSearch what it has to be done, we need to specify special type of the index. And type of the field, it's called completion. And basically, when we specify this type, OpenSearch will understand for the field of the name title, we need to build special data structure. It's usually graph data structure. In our case, we will represent as 3. So, what these 3 represent? Suppose that we want to insert Harry and hello. And during insertion, OpenSearch will take this data and build a tree around this. For example, with Harry, it will put the H as the first root. With A in E, for example, with Harry and hello, A, it will use as child of the root node. And basically, it builds from the root of the H a graph and tree that will be used for retrieval of the data. And that's why it's guaranteed also fast retrieval, because it's basically just reversing the tree and analyzing the rest of the tree in childs and retrieves the data, and user can be quite happy with low latency results. So, but here's the trick. You need also to use special type of the query. It's called suggest. This suggest is quite powerful because you can have few suggest title. For example, you want to suggest title, you want to suggest author, you want to suggest plot. That's why you can combine a few suggestions in one. In our case, we just have one, suggest title. But we also want to let it know how we can search for this title. That's why we need to specify the prefix. In our case, we can Harry. And after that, which field you want to use. In our case, title. And after that, we have a lot of we have results. One of the advantages of this method is that it have faster retrieval, low latency results, and also And also it's suitable for prefix message. Another drawback, also it's possible to have weighted suggestion. Weight your suggestion and what's more suitable for you. The next one is search issue type. Basically, search issue type, it's another type of the auto-completion. As well, you here need to define your type of the mapping. You also need to define the type of mapping and how you want to basically match your fields. And you can see here to specify which field you want to use for the auto-completion, you need to use type search issue type. After this, OpenSearch again will understand that, okay, for this field we need to build special data structure. But what kind of data structure? In this case, it will be build sub-fields, and also sub-fields will be as well optimized for better retrieval and for faster retrieval. One of advantages of this method that is also have good performance, low latency, and could be used for full search. I will demonstrate you as well. But how basically OpenSearch will store the data? In case we again have a title, in our title weather is great. During insert, OpenSearch process your data, will separate the main field title, will split sentences in separate words and keep the strings as area of strings. After that, depends on how much n-grammas you specify, it will create combination of these n-grammas. Whether is great. And during retrieval, it will match against these n-grammas and titles to find the better results. As you see, this combination can be powerful because it will also speed up the process of retrieval. And also, via using this method, you can have a full text search as well. And basically, how we can retrieve our data with this data type. Again, we need to execute search, specify our index movie, and specify the body. With this type of auto-completion, I like that we can use multi-search because multi-search have a lot of capabilities. For example, you can have boost for special field, fuzziness, and other slot in case your user will misspell some mistakes or have different, doesn't know proper spelling. So, and basically how we can do retrieval. For this, we again need to specify fields. As OpenSearch creates subfields, we also need to specify these subfields in our fields value. One of the things that with OpenSearch you can use wildcard. So in case you don't want to always write all fields, you can try to use wildcard. Additionally, what you can use bool prefix is we specify that we want to match the prefix, but it's possible to have different types. So, for example, for a full text search, and we specify that it should be Harry. Now let's go to our demo. So, in case of our demo, I need to move around a bit of patience. Okay, great. We see everything. I a bit increase, so I cannot increase. I increase. Okay, perfect. Everyone see everything. So we have different types: prefix matching, suggest type, and completion suggester. With prefix matching, we did simple implementation. We did not use slope on fuzziness, just to see how it works, so it's the simplest solution. And we type Harry. And we can see that some of them, for example, Harry and Bunny, Harry and Sloman, and Harry and Benson. But let's suppose it's late night, you have a lot of work, and you don't remember how to spell Harry. And you spell like Harry. And you see that you don't have results, and you cannot watch any movie. But in case we implement a bit more powerful and use completion suggester. And let's try to put like Harry. We can see that it shows Harry and Bunny, Harry and Benson, Harry and Shlonoma. But we also see inherit. We see Harriet because of the fuzziness that we have in completion suggester. In case you misspell something, OpenSearch will still understand and still give you some results, even the results is not fully match what you write. It's true power of OpenSearch. Now let's go back and let's make conclusion. So
We want also to apologize because we don't have Harry Potter in the selections.
yeah, yes. So what we can tell about OpenSearch. So OpenSearch has integration with a lot of services. For example, you can easily ingest your data. Right now, I know there's OpenSearch pipeline where you can just specify source and destination and can help process your data. It's quite also easy to scale. It's very good in performance. You also can analyze your data and do aggregation via different functions and capability. And finally, if you want to search, use OpenSearch. And thank you for your attention. Yeah.